Okay, so, sorry, that thing was in my way. Okay, so we're finishing up 4-1 today. So we are going to start with, can you give the angle measure represented by each rotation? So a rotation or a revolution is just one time around the circle. And remember that counterclockwise means in the positive direction, clockwise is in the negative direction. So when it says 6.1 rotations counterclockwise, it's telling you go around the circle 6.1 times in the positive direction. So you just do 6.1 times positive 360 and you get your angle. Alright, if I asked you to do a half a rotation clockwise, that means they want you to go halfway around the circle but backwards in the negative direction. So you do 1/2 times negative 360 and you get your angle. So again, rotations is all the way around the circle, so times 360. And clockwise or counterclockwise is just, am I going positive or negative? Alright, so next we are going to talk about, what are we going to talk about next? I guess it doesn't really matter which one of these we do next. Okay, we'll just do this and then we'll talk about the inside of this. Alright, so again, you will get this handout when you come back to school. I'm pretty sure I have it digitally, but to get it printed where you can fold it correctly, I don't know. So you may want to just write this stuff down in your composition book. Or if you can print, I'll have it if you can figure out how to print it to where it looks like this. Anyway, so complementary and supplementary angles, not new information. Complementary angles are going to add up to 90 degrees or to pi over 2. All right, supplementary angles are angles that add to 180 or add to pi. All right, and I left off the word pair of because it has to be 2 angles. 3 angles can't be complementary. All right, so examples. I'm just going to let you look at all of it, take it all in. All right, so we're going to find, if possible, the complement and supplement, because if an angle is too big, then it's not necessarily going to have a complement or a supplement. All right, so for 18 degrees, that would have the complement because it's less than 90, so I can add something to it and get 90. So to figure out the complement, you just subtract your angle from 90, and you figure out what would need to be added to it. To get the supplement, you subtract it from 180 to figure out what you would need to add to it to get to 180. All right, for 130 degrees, that's more than 90, which means you can't find its complement. And then supplement, you're going to subtract from 180, and you get its supplement as 50. All right, so in radians, remember that it's not any different. It's just you have to deal with fractions, which I know that y'all don't like. All right, so to find a complement, we have to add up to pi over 2. So we're going to subtract our angle from pi over 2, but we're going to have common denominators. So we're going to have to change pi over 2 to 6 pi over 12, and then subtract that 5 pi over 12. For the supplement, it's going to be pi minus your angle, because supplement means add up to 180 or pi. So change it, so common denominator, so that's 12 pi over 12. Subtract the 5 pi over 12, you get 7 pi over 12. All right, for 5 pi over 6, 5 is more than half of 6, which is why I know that there is no complement because that's more than 90 degrees. Remember, 90 is pi over 2, so 5 is more than half of 6, which makes this bigger than 90 degrees. So there is no complement. If you try to do the work, you get a negative, and then you would know you were wrong, because complement supplements are always going to be positive. All right, to find the supplement, you do pi minus 5 pi over 6. But we got to change pi to 6 pi over 6 and subtract, and we get pi over 6. All right, so that's complement supplement. The other thing that's on this paper is we have degrees, minutes, seconds, and converting from degrees, minutes, seconds to decimal degrees. All right, so decimal degrees is when you have regular numbers like 42.5 degrees. All right, degrees, minutes, seconds is when we've broken it down. So if you think about longitude, latitude, if you've ever worked with that, those are given in degrees, minutes, seconds. if you think about the whole world and you're trying to label where something is, well, as big as the Earth is, if we just only do degrees, then that's a whole lot of area that we are talking about. So we had to come up with a way to break that down. So every degree is broken into 60 chunks called a minute, and every minute is broken into 60 chunks called a second. So just the same way the clock is broken up, actually. All right, so we need to remember these conversions to be able to convert from degrees, minutes, seconds to decimal degrees, and vice versa. All right, so a degree, like an hour, has 60 minutes. A minute has 60 seconds. And so that means a degree has 60 times 60, so 3,600 seconds. All right, so when you're going from degrees, minutes, seconds to decimal degrees, you're going to make sure you don't round. Try to type everything in the calculator at one time. It makes you more precise. All right, so for the degree part, you hold on to it. It's your whole number. To get your decimal pieces, you're going to say that 27 gets divided by 60 and 4 gets divided by 3,600, because this is 27 out of 60 minutes, and that's 4 out of 3,600 seconds. All right, so then you type this in your calculator all at one time. Remember that fractions should go in parentheses, so we're going to do 2 plus and then 27 divided by 60, and then plus 4 divided by 3,600, and it doesn't like my calculations because I forgot a parentheses. Okay, and then you get your answer, and at that point you can round to whatever you were told to. So this says nearest thousandths, so we want 3 decimal places. All right, so try the next one, and then you can check your answer. All right, so 74 whole degrees, and then 8 out of 60 minutes and 14 out of 3,600 seconds. Type that in your calculator, and you should get 74.137. If you forget the parentheses, I don't really think it's going to matter in this particular case. Okay. All right, I'm showing you how to do this by hand. There are buttons on the calculator that you can use if you have the graphing calculator, but those buttons aren't on every calculator. All right, so if I'm going to go from decimal to degrees, minutes, seconds, again, don't round. I'm going to round, so whatever, but never mind. It says don't round until the end, but it's hard to keep up with everything. All right, so I'm going to convert this. We want to be rounded to the nearest whole second. So at the end, we're going to round to the nearest whole second. So to do it, here are the steps. The whole number is the degree. So we know we have 5 degrees. All right, so then we take the decimal, the 0.128, and we turn it into minutes. So to do that, we times 60, because there's 60 minutes in a degree. And we get 7.68. Well, the whole number is how many minutes we have, and then we have 0.68 minutes left. All right, this is 0.68 minutes. So to convert that to seconds, we still just multiply by 60, because it's 0.68 minutes that we're going to times by 60 and get 40.8 seconds. And it said to round to the nearest second, so that's going to round up to 41. All right, so try the next one, and then see if you get the same answer as me. All right, so 34 whole seconds. That's not a second, that's a degree, sorry. 34 whole degrees. And then you do 0.817 times 60, and we get 49 minutes. You do 0.02 times 60, and you get 1.2 seconds. So we get 34 degrees, 49 minutes, and 1 second. Okay, so in your calculator, it's really easier for most people to just remember how to do it. But if I'm going to go from degrees, minutes, seconds to decimal degrees, I can just type this in like it looks. All right, I'm going to have to show you the whole calculator because you got to see where the buttons are coming from. All right, if you have this calculator, if you downloaded it on your phone or if you just have it, you can type in 2, and then right here it says angle. So if you go second angle, you can get the degree symbol. 27, back to angle, and you can get the minute symbol. But then when it comes to getting the seconds, they put it down here, and it's in green. So you have to do alpha plus sign. Once you get it typed in like that, you hit enter, and it gives it to you as a decimal. All right, going the other way, so let's take this one. If I take my 5.128, then if I go to angle, number 4 says convert to degrees, minutes, seconds. So go to the angle menu and choose that, and it gives it to you. And you just got to remember to round that last number because they said to the nearest second. Okay. What else do we have for today? Okay, so arc length is a formula. All right, so for a circle of radius r, a central angle intercepts an arc of length s given by this formula. So this is saying that the arc on the outside of a circle is the radius times the angle. So if I have a circle, then the angle times the radius tells you how long that is. So the bigger the radius, the longer that piece of my circle is going to be. And you know I can't draw at this point, so pretend like this is a nice pretty circle. But if I kept drawing bigger circles that intercepted that same thing, then this arc length would get longer and longer and longer. And it's in proportion to the radius of the circle. So to find the arc length, you do the radius times the angle. What's really important though is for this to work, you have to be in radians because the radius is how you, radians is how you measure the outside of the angle. Okay, so I want to find the length of the arc on a circle with radius r intercepted by a central angle theta. So they give us a radius, they give us an angle, but they were not nice enough to give us the angle as a radian. So the first thing we have to do is convert. So remember we learned that we multiply by pi over 180 to convert to radians. So we do 240 over 180, reduce that, and stick a pi on it. And if you struggle with reducing fractions, remember that your calculator has a fraction button. So 240 divided by 180, if you do math and enter, it will give you a reduced fraction. All right, so now using the formula, we're going to do 4 times that angle. We get 16 pi over 3, and if you just type that in your calculator, 16 times pi divided by 3, you get this as your measurement in inches. All right, so another one, try this one and then see how you do. So you've got to change this to radians. So 160 pi over 180 reduces to 8 pi over 9. So 27 times 8 pi over 9 is 24 pi, because 27 times 8 divided by 9 is 24, and then stick a pi on it. And then if you type that in your calculator, you're going to get 75.398. All right, so another formula, linear and angular speed. All right, so linear speed is the arc length divided by time. All right, so your angular speed is the central angle divided by time. So linear speed, it's the difference in whether you're like inside the circle or outside the circle. Like if you're riding a merry-go-round, are you going faster if you stand close to the middle or close to the outside? Is why there's 2 different formulas. So linear speed is if I'm on a circle, if I'm traveling out here around the edge versus if I'm traveling in here. So the radius is going to come into play there. So arc length, we have radius times angle, right? And then we divide that by time. And then angular speed is the central angle divided by time. All right, so a carousel with a 50-foot diameter makes 4 revolutions per minute. Find the angular speed of the carousel in radians per minute, and then find the linear speed in feet per minute of the platform rim of the carousel. All right, so the first one, if we are going to find angular speed, we are going to do the central angle times the time. All right, so the central angle, Well, all the way around is 2 pi, and it said 4 revolutions. So 4 times 2 pi gives me an angle of 8 pi. So revolutions times 1 trip around the circle gives me the angle of 8 pi. And it says per minute, and it's 4 revolutions per minute. So we just have 8 pi over 1. So it's 8 pi radians a minute, or if you multiply that, 25.133 radians per minute. All right, so next we have, they told us the diameter is 50. That means the radius is 25. We know the angle. We're going to have to go back and use that arc length. So radius times angle. So 25 times 8 pi, because that's the radius, that's the angle, and in 1 minute. So now we have 200 pi feet per minute, or 628.319 feet per minute. All right, so last formula, area of a circular sector. So first of all, a sector of a circle looks a lot like a triangle, it's just rounded, right? So it's 1/2, for a triangle, it's 1/2 base times height. Well, for the circular sector, it's 1/2 of pi r squared times, there's no pi there, sorry, my brain just went to something else. It's 1/2 of r squared times theta. So the radius squared times theta, and then 1/2 of that. Okay? All right. So if I want to find the area of the sector of the circle of radius 2.5 feet with a central angle of 225 degrees. So they're telling me that this is opened up 225 degrees. The radius is 2.5. Well, that's all I need, except that I have to be in radians. So we're going to change 225. We're going to call it 5 pi over 4. I just looked that up on the unit circle because 225 is on there, but you could also convert it the same way we've been converting. All right, so we do 1/2 times 2.5 squared times 5 pi over 4. Type that in your calculator, and you get 12.272. All right, I think that's it. Yep, that's it for Thursday. We're finishing up section 4.1. Again, if you have questions, please let me know. Go back and listen again to the part that you're confused about, but then email me and let me know what your questions are.